So good morning friends and welcome to the another session of structural analysis 2. I welcome you all on a very fine morning and I can see people are joining slowly, so we'll wait for a couple of more minutes and let them join together so that we can start our session. However, it's largely a student oriented session today because driven by the students, because I'm going to give you certain numerical on the truss analysis by energy principle, uh, principle number 2, and where you need to work largely compared to me, and you will be working on the solution also. It's a small numerical, but again manageable within an hour, I think, if you pay attention and do work with me. So bring your tools or writing tools with you before we start, before I suggest you. And meanwhile, let me go through the contents that we have been following. We have been studying strain energy principles for structural analysis, in which we have referred largely two principles. Principle number one, which is useful for determinate structures, but to identify the deflection and rotation, that means the degrees of freedom in the structure, while the other principle number two provides us how we can obtain the unknown reactions and the internal forces in the members, which are indeterminate largely, right? So in this series we have been discussing so many interesting structures which are indeterminate largely, and we started employing our energy principle number 2 to to solve this kind of structures like this: continuous structures, prop cantilevers, and now we have reached to the stage of this structural analysis for trusses. So if we recall the last session, which is fortunately here with us, we can see that we have analyzed this truss, which was externally determinate but internally indeterminate by 1 degree. So I explained you completely stepwise how we can carry out the unknown force calculation in the members. Once we have that force in our hand, we can obtain the rest of the forces in form of this table, right? So we'll be taking help of this previous steps to solve the next numerical also. It's again a truss problem, because I want to ensure that you have learned it properly. You can reconnect. You can get reconnect with your earlier content, which we have discussed comfortably in the last session. And in the tomorrow's session, I'm going to apply energy principle number 2 on the frame structures, right? So that is also equally exciting. But before that, before we go for that, let us ensure that we are through with this technique of structural analysis with the energy principle number 2. So I'm going to give you a problem statement first, and then let's see how we can solve them, and where your role becomes very important, because you have to respond to various questions as usual, and you will be doing a parallel job with me, parallel work with me in terms of solution. However, I'll not be guiding you completely. Certain things you have to obtain, right? So let me give you the structure first, which you can copy in your notes, and then we'll carry on. So here is a truss. Right. So let me go through it, because while drawing it's difficult to speak. It's all about controlling your mind, you know, and with your age, you know that it becomes tough and tougher. Anyways, I will try my level best. Okay, that's good enough. Again, 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6. So it should look logical when you are drawing a structural sketch. Even sketch should be quite logical. So that's why. Again, 1, 2, 3, 4, 5, 6. Accidentally, it is correct. So this is a truss in which we have additional members like this for a better stability of the structure, and we can name these joints like in a sequence: A, B, C, D, and E. So this is A. Let me use a different color for better marking. Like this is A, this is B, This is C, this is D. Again, it's a kind of solved numerical from your reference, which you can refer later also if you have that source. Otherwise, you can refer to this work, which right now we are carrying out, just for a better understanding how we can strengthen our concepts of the, sorry, it's not a hinge here, it's a continuous fixed edge, right? It's a fixed edge throughout. It's a wall kind of structure where it has been embedded like rigidly connected with these points. Okay, so definitely we can expect some of the reactions at the support, and for that you may need to work upon. However, we will not be bothering about the reactions at this moment. Largely we'll be uh, bother about the other member forces. And first, let me give you the value of the forces which are suspended over here according to the question. Again, I will be avoiding the or I can introduce the value of E and I for your reference, which you can utilize for calculation. There are 2 point loads suspended over here, one force here and second force is there, which is 20 kilonewton again, right? So now we can have the dimensions again, and the dimensions are like 2 meters is the height. Okay. Now you need to work upon this. You will be working more than me in this numerical. I'm just relaxing by sitting back and asking you the questions. So naturally, this angle is of 45 degree, right? All right, then this is enough for us, and we'll write down the values of E and I in this case also. Let me give you E, that is 2. Of course, it is a steel member, so 10 to the power 5 Newton per mm square, and moment of inertia of the members, sorry, the area, not the inertia, the area where we require cross sectional area. That is 1000 mm square. Yes, it is 1000 mm square. Okay, friends. So these are the details you have. You need to work out the member forces. That is a general instruction. Calculate member forces in each of the members of this truss system. So visually, it gives you an idea that it is internally indeterminate structure by 1 degree. So definitely we need to remove one of the members, and naturally that will be done by removing one of the diagonals. So we'll be removing this diagonal. Right? We have identified that member BC. So our solution started. SI external is I would say 0, and SI internal is 1. So we'll be removing redundant redundant as member BC as of now. So we will definitely replace it by force P. Right, so that later on we can take partial derivative of the stored structural energy in these members, and we can take the necessary steps ahead. So the second step is to start analyzing the members. So let's go for it by method of joints. First, we'll start from joint E naturally. So now your turn starts. Give me the values of all the forces. We will assume all the forces are in tension at the moment. And if the sign comes into the different direction, like if sign is negative, then we will assume that this particular member is originally in compression. Right now it is outstanding, so that is tension, and there is a force of 20 kilonewton here. This is a member, this is joint E, so this is FEC, and here it is FED. Now I'm not going into the detail of each and every step. Largely you have to directly suggest me the value of the forces, force in EC and force in ED that you need to work out. I'll be sitting back now and you have to give me the answers because you know how to analyze this joint, right? This is 45 degree. I have already given you the details. Now, once you are done, raise your hand. So I will be receiving your answers and then we'll be going ahead by cross-checking at least two answers together. So at least two people are required to answer this question. As we have already studied and discussed how to do it, I'm not going to repeat the same scenario because this you can see here I have elaborately explained you, and now it's your turn to come back with the solution. So it's a simple method of joints which you need to employ in this analysis of this joint. So divide the force in two components. I'll be guiding you, giving you tips and tricks. You can simply divide this EC member which is inclined with horizontal axis by 45 degree. Divide them into components FEC sine and FEC cos and apply your old level of the knowledge of the analysis of the truss and obtain these two forces for me, right, and for the rest of the class. And those who are not doing any calculation, it is not good. I would suggest that everybody should, you know, calculate these force exercise in their notes, right? So today I'm expecting some new people, new students should be responding to this question. However, all are welcome. uh, Birendra is there. Yes, Birendra.
Yes, sir. So I got FCE 28.28 and FED minus 19.97.
Okay, this is 28 point.
28.
Okay, in my calculations to 9, but I'll go with your answer 28.28. And
Yes.
what about ED?
Minus 19.97.
So can we go for 20, right?
Yes, sir.
Approximately 20. Okay. So you are right that one answer we have got in terms of negative value. So actually it is in compression, while here we have got positive. So it is tension itself. So this member which is inclined, that is, you are right. So CE is in tension. I will mention it here itself for a safety. And this member is in compression, right? DE. So with these two initial calculations, now let's go to the joint C. So now I advise all of you to carry on with joint C, which we can write here, because ultimately you know what you have to do, right? So it's just a matter of calculation only now. So how many members are connected at joint C that you need to identify. If you are uncertain about the force direction, take them positive. That's it. That's the only suggestion from my side. And largely you will be getting the negative answers. If you have negative answer, that means it is in compression. So here again we will continue with this EC member, which is actually now 28.28 kilonewton, which is known to us, right? And rest of the forces are not known to us. So this is FCD, this is P actually, and this is FCA. Okay, so we have named this things. This is joint C, and now we need to divide. I'm giving you some guidelines. I don't need to instruct you separately. You carry on with your own calculations. I don't mind. I'm just giving you some guidelines and hints. You can divide these forces into components like this, and you have all the inclinations. Needless to add that this is also 45, so you just don't need to worry about that. You can have your inclination and just give me the values of these members. Let us say, Birendra, you can mute yourself. Okay, so let's keep writing the required values. So here I require force in the member like FCA, right? So I'll be writing it here, FCA. I need P, I know, so it is P. So member CB is just P, that's all, and FCD I need. Okay, so you can come back to me once you are done. You can raise your hand. I will be unmuting yourself, and you can respond to the class also. Largely, we can write down FCB is P. That's all. Since it is tension, we'll keep it P itself. So you can collect all the vertical forces for sigma V and collect all the horizontal forces in sigma H, out of which one force is known to us, the rest of the forces are unknown to us. In terms of unknown forces, one set is of in terms of P, so use P value, right? And only FCA and FCD should be reflected in the calculation. Don't reflect FCB but reflect P. Use P value. So I'll be waiting for your answers, and you just need to write your equations like this. Sigma V equals to 0. So how many forces are there? FEC sine 45 going down, so it becomes negative, minus FCD minus P sine 45 gives you equals to 0 term. So we have considered all the three vertical values. Darsha is there. So yes, Darsha,
Sir, I am getting FCA is equal to 20 kilonewton.
FCA is 20
Kilonewton.
kilonewton. How come? I mean, are you sure? Because just now here itself, I have written something like sigma h equals to 0 in case. Uh, let's write down the horizontal force like minus p cos theta. Then we have minus FCA. Then we have plus FEC cos theta. So I think you have missed out one point over here, that is of P, isn't it?
Yes, sir.
So rework on that and tell me the revised value. It's fine, but you just need to tell me what is your revised answer. I hope rest of the students are doing well, and I insist that you should also keep calculating the values on your own. Right? So you can unraise your lower your hand. I have lowered your hand. So when you are ready next, you can raise your hand again. Those who have the answer, and they can give me the revised answer. Don't make a mistake like this. Never forget to include P. Otherwise, you will not be able to carry out your calculation for partial derivative step. Do not hurry up. There is no need to rush for these calculations. There is no competition going on. But take your time and be wise enough. Consider everything in calculation. Don't miss anything. So I am sitting back on my chair, seeing you guys are working on this. So when you are done, tell me I can unmute yourself. So this is why I have guided here you for sigma h and sigma v. So it's not that tough for you to identify, because fortunately all angles are 45 and you know the value of sine and cos both are 0.707 in case of angle as 45 with horizontal. Yes. So Birendra, yes, Birendra, Darsha, Birendra, Prashant, many people are there now. Let's go to Prashant for this time. Yes, Prashant.
Yes, sir. FCD is equal to 0.71 P minus 20.
FCD is going to be 0.71
71 P minus 20.
P minus 20. And what about FCA?
Minus 0.707 P plus 20.
So it's a vice versa kind of thing, right?
Yes, sir.
All right. So as you can see, they are reverse in their nature, and that's completely fine with us. And I'm sure that the other people are also getting the same answer. What about the other people? Okay, Prashant, you can mute yourself for a while. Let everybody,
Thank you, sir.
so let others to contribute to this answer. Let's cross check whether other people are getting the same answer or not. Then we can say if it is correct. However, the P on this case, let us say for CD here, we need to bring these things on the other hand. So both should be negative. Like P will become positive, FEC will also become positive, but on this side we have negative sign. So when I change this sign, both will again become negative. So in my view, I think it there should be a negative sign for this also. Like here, there should be negative sign. What say others? Like according to them, because see, it is very obvious that if you are working on this FCD again, I'm highlighting. If you send this person on the opposite side, it will become first. It will become positive. This will also become positive, and then if I want to remove this negative sign, I need to apply the same on the other side, so both should be become negative again. So that is what my interpretation. But Darsha, what you want to say now? You
Yes,
can.
sir. Both. I am getting both negative.
Okay, so let's continue. Anyone else? Yes, Prashant, what do you want to say?
Yes, sir. It was negative, sir.
Okay, okay, that's fine. That's completely fine. It happens, no problem. So I will put negative again here for correction point of view. And now let's go ahead for FCA. Let's reconfirm once again. FCA. This person becomes negative. This becomes positive, but later on, this again becomes positive, and this becomes negative. So positive negative combination. EC value we have, so this is positive and this is negative. Is it okay with all of us? Like anyone else would like to contribute? Anybody else who is calculating apart from Prashant and Birendra and Darsha? Anyone else would like to confirm? I just need a confirmation of FCA from any other student in the class. Anyone can raise hand, and I just want to confirm it. Should I randomly select, or you will raise the hand? Anyone? So this dialog box is still open. Anyone can raise the hand quickly. Make it fast. Make it fast a little bit. Don't rush, but don't be so slow. FCA, it's very simple, right? It has to be right like this. But again, I just want to know from you people. And by the way, do not forget to mention your enrollment in chat box, dear friends, so that those I can see only 26 entries are there in the chat box, while the 32 students are attending this class. So please enter your details without a delay. First, go there and enter your details if you have not done it yet. Yes, it's moving on. 29, 29. Yes, and let's confirm this. Anyone else would like to confirm here? FCA or happy is there? Happy. What is your answer, dear? On FCA, I hope you are calculating. Or we have Vivek here. Vivek, would you like to respond? I have allowed you to unmute yourself. Getting the same answer? So, okay, let's go back to Prashant. Prashant, where are you? Raise your hand. Okay, so is it fine? FCA, according to you, FCA is correct?
Yes, sir.
Okay, okay. So now let's go ahead and carry on with these answers. So the next will be the joint D here. Right. Let's go for that. So what was the step number? This was number 2, number 3, number 4 we have reached. But before we do anything, let me repeat this slide for future purpose so that I can duplicate them so that we can carry out the calculations comfortably, okay, before we write anything on that. All right, so it's merely the next 25-30 minutes, so I insist everyone to continue to work, right? Joint D, I would say one of the most significant joint in this structure because it carries a lot of connections. This is compression. We know that this is nothing but DE, I'm supposing. Again, on this side, we don't know what will be the thing. So it is joint force DA, if I'm not wrong. Here you have a force which is known as FDB, if I'm not wrong. Again, we have a vertical force. Sorry, we have a vertical force here or a member largely DC. And have we got DC? Yes, we have got DC. So we'll keep it as it is, right? Intention. So FDC. Do we have anything else here? No, we don't have anything. One, two, three, and four. Four connections are there. One, two, three, and four. So we know that now, and you can go ahead. All guys, you can carry on with the calculations. The only thing is you need to separate why color is not changing, giving me challenge. So I'll go with this and I will change it from here. Okay. So it's going to be the parts like this. Okay, these are the two separations of this inclined force like this. So now you can come back and you can tell me the forces for your convenience. Again, we'll put down the steps: sigma V, sigma H. Sigma V should be mentioned here. Pela Parinda madam pass. Okay, so FDB, right, should be the sine theta plus FDC. That's it. Do we have only two vertical forces? Yes, that's correct. So equals to 0. And as far as horizontal force is concerned, FDB cos theta negative and negative FDA, then negative FDE, right? Have we considered all the horizontal forces? Yes, it is 1, 2, and 3. So all are considered. Now it's just incorporating the values those we have. So we don't have anything on the side of dB except the simplified value that we can write here 0.707. But we have DC, so we'll write DC here. It's both terms negative, so we'll write down negative 0.707p minus 20, right? So you can do either of the things. You can send this term on the other side and divide it by 0.707, so this gets cancelled. However, this will become positive. Again, the another value will become positive. So this FDB should be like this. Okay, so that is here P. It will become positive since this side is positive, so we don't need to do anything on this. Plus 20 divided by 0.707. Okay, so that you calculate. Meanwhile, I'll be coming back to you. Give me a second, I'll be coming back. Okay, so what's your answer, friends? What is the answer for FDB? FDB should be what? Oh, by the way, we missed one thing. Nobody drove the attention. People, we have 20 kilonewton here. How can we forget? Okay, so not an issue. This is negative 20 here, right? So that I will be adding here. That's it. So that's that. So now you can tell me what's the value of dB here. Oh, by the way, what's the value of dE? Let's go back. Let's go back. What is dE? Do we have that value? Yes, we have dE, and that is 20. dE is there. Do we have dA value? If we go back, dA. So you can get your dA from here, and then later on you can use it somewhere. But I think we need to rework upon that. So let's rework completely. This is actually dB. I think I have made a mistake in, yes, I have made a mistake in writing these names of the forces. So such a blunder should be avoided immediately. Please rework on this. I'm giving you uh, the revised write-up. Please make a note on this. This is force FED. Right. On vertical we have DC, right? So this is FDC. Okay. And on inclination we have FDA, and this becomes your unknown force, so that is DB. So please make a change over here, right? Now let's ensure anything is not being missed out and rightly written also. This is DB, this is DE, this is DC, and this is DA. And we have also included 20 kilonewton. So DA, DB, DC, and DE or ED, whatever. So now this looks proper. So please follow that, and pardon this missing content which I just missed out. You should not be, doing it in exam at all. So don't now focus on this. Just come here, come here, and revise it. So it is better that if we rewrite and everything again, so that we can reach to the right answer also. Right. So let's revise it for a while. So sigma v and sigma h, sigma v now we will rewrite. You may be doing the same with me right here. Why black color is not there? It is there. So that is negative 20. Now what else we have? F dA, I would say sine theta, right? And plus we have F dC equals to 0. Okay, both are positive upward, this is downward, so that is fine now. But we don't have dA value, so we will keep continuing writing it. F dA 0.707 plus we do have DC value, and that is will write here. So that is negative 0.707 times P minus 20 equals to 0. So now I think you can give me the value of FDA, right? Now you people work upon. So I will uh, allow you to re-raise your hand. I think there is a young zone. Yes, young zone.
Sir, I'm getting FDA P plus 8.29 and FDB minus P minus 8.29.
Okay, let me write first FDA according to you what it is. P plus
P plus 8.29.
8.395.
29. 29.
29. And what is F
DB
dB?
minus P minus 8.29.
All right, let's check them up. Okay, you can carry on, and let's wait for others to respond on this. FDA. Let's confirm this once. So we'll be waiting for others to respond. Meanwhile, we can expand this like FDA 0.707, just as an expansion of the same term, then minus 0.707 times P minus both are negative, so minus 40 equals to 0. So let's go ahead and let's divide the things. 40 divided by 0.707, that gives you 57.50, 56.57. So FDA I will be getting as P, right, plus 56.57 kilonewton. So that should be the simple calculation, and I hope all of you are getting this, because this 0.707, when you send this term on the other side like this, it is very simple mathematical calculation. FDA 0.707 times FDA equals to, when you bring this term on the other side, it becomes positive, so it is 0.707 times P, and this negative 40 also becomes positive, and then later on you can divide it by 0.707 again, so it becomes P, and this increases to 56.57. So I think Yingzong, you also need to take care of this answer, and others are also advised to continue to this answer, right? And since now we have FDA in our hand, we can write down comfortably the sigma uh, H also for this system. So I'll be removing couple of parts from this. Let me remove this, because already we have a right answer written on the above space. So I'll not be changing the page in case, because we want to write equations from this figure. Don't look at to this now. This is your right figure. So let's take one by one, like F, let me write it here. Let me write it. Let it look ugly, but F dA cos theta, and that is negative. Then we have negative f dB, then we have negative f e d, and that is equal to 0, right? So now we shall be using values which are available with us, like minus f dA, so minus p plus 56.57 into 0.707 minus f dB minus 20 equals to 0. If I'm not wrong, ED value is 20. Yes, here you can see. And there is no need to bring again the negative sign along with along with us, because we have already changed the sign of this member, which is in otherwise in tension, but we have shown it that is in compression. So already we have taken care of the numerical sign. So here it should be only 20, not the negative 20. That care should be taken. So now we just are ready to write our further simplified view, like 0.707. I thought that you will be doing it completely by you, but anyways, ultimately uh, 56.57 into 0.707 gives you 40 again. So let me write down 40 here directly, right? Minus FDB minus 20 equals to 0. So friends, I'm going out of this line, and I'm writing it again. FDB equals to, this negative term becomes positive, so it is 0.707 times P, right? And this is negative, negative gets adding, so 40 plus 20, 60, and goes on the other side, becomes, this is negative, that we have to take care. So this is 60. So now ultimately, finally, dB is negative 0.707 P minus 60. So that now largely we have worked out all the member forces, except the member, we have worked out all the members, And please remember that AB member is not in picture because it's a part of the wall system. So it's largely is again considered as the member which is already without any force. So which is a part of the member system again. So let's write down all the other members in a list, like how many we have, 7 nearly, right? So we'll create a table here, and we have largely analyzed all the members together. So we'll create a table, like we'll consider member here, member. So let's write them down one by one so that we can create our table. Like uh, we'll write down EC, then we'll write down ED, right? Joint wise we can go, like joint E is addressed now, joint C is being addressed, C A, right? Then we have joint D, so DA will write, 6 is D, B will write, and finally we'll write BC. Okay, so I think it's quite good enough to create a table. Because you need a table, as you know, you need to do lot of calculation, I mean multiplication in future. So I'll be going little fast in this term. So let you help me write down the F values. Who will quickly give me the answers of all these values? Let's go to Darsha. If is it possible for you? Where is Darsha? Okay. Can you help us? What is the value of EC here? Force in EC?
Sir, 28.28.
28.28. Then what is the value of ED?
Sir, it is minus 20.
What's the value in CD?
Minus 20 minus 0.707p.
So let's bring it out. So minus
20 plus 0.707p.
20 plus 0.707. Is it okay? The way in which
Yes,
I have
sir.
written.
Yes, sir.
Okay. CA.
Sir, it is 20 minus 0.707p.
DA.
56.58 plus p.
DB.
It is minus and in bracket 60 plus 0.707p.
And BC is actually P, right?
Yes, sir.
So now, very well, thanks for this help, and let's go to somebody else who can quickly confirm all the answers. Are there any changes? Who would like to raise and confirm the answers? Raise your hand and confirm the answer. Uh, we can have Prashant, Birendra, like Yangzong, anyone, those who have been responding till the time, I hope, or somebody else from the open audience, they can also jump in and confirm the values here. Otherwise, you guys can directly go to the summation of this, and before that, we can go for del f upon del p. That's the only primary work that you need to carry out. So it becomes 0 here again. This becomes 0. So here it becomes negative 0.707p. Here it becomes again negative 0.70 p times. Here it is again 1. Here it is 0. Negative 0.707 times p. and here again it is 1. So we have 1, 2, 3, 4, 5, 6, and 7 values. So now you people are smart enough to take this further from this stage, because most of the work we have carried out here, we have completed here. You know that what else you need to add, that is the length of the member, because ultimately you need to multiply the length with this f, sigma f. So you require sigma f here also, by the way, and sigma f into del f upon del p. So go for this addition, keep on adding them, and just add them together by multiplying them with the length, of course. So what is the EC length? Have we worked it out? Anyone would like to tell me what is the length of this inclined member? Just for a quick reference, let me draw the rough figure here for your reference. It is crossed like this, right? This is 2, this is 2, this is 2 again. So this inclined value, Birendra is there. Yes, Birendra. What's the length?
Yes, sir. 2 meters, sir.
2.
Meter.
Okay.
So I think there will be only constant value.
Yes. Okay. Like EC, we have 45 degree. So what is the length of EC again? Here you have 45 degree. So what is this inclined length? That's what I'm asking. Like, what is EC? It cannot be 2 meters, because otherwise these and
It will be 2 roots, sir.
so what is the answer actually? What is the final answer? So all the diagonals will be of,
2.82, sir.
yes, 2.82, and
Eight.
all the others will be of 2 meters, like ED. ED is 2 meter. Then
Sir,
CD, that's again 2 meter.
sir, I have a question, sir.
Please carry on.
Sir, I think df del f by del p, there will be only
Only
values constant.
value constant. I'm not getting you. Like,
Like in 0.70 p, there is a p, but I think there will be only 0.70
no, no. In which member you are discussing?
cd.
C, D,
Yes, sir.
member number 3. So according to you, is your answer differing?
There will be only numerical values
Yeah, yeah.
like.
Okay, that's what, because of the habit, right? Okay, so thanks for correction. Anyways, that's good that you have pointed me out right. By the way, let's carry on. That's it from you, Birendra. That was the only point. Okay, so anyways, this is a good point for enlightening me on this. That I wrote it like along with P. Even I, after taking partial derivative, this is what generally happens when you are rushing somewhere. Okay. So please make a correction over here, everyone, every student doing this. Please remove this P, because it does not exist, or it should not exist here. How wonderful it is! Like, I have written it correct here, but I did a error over here. Okay, all right. Then which are the other values? For EC, we have written 2.28. ED, it is 2. CD, it is 2 again. Like CA, where is CA? CA means again horizontal, so it is 2 again. So I think it is mismatching a little bit. This is okay. This is 2 meter. This is CD is 2 meter. This CA is 2 meter. Now DA or AD. So that is diagonal. So naturally it will be 2.82, right? That is DA is considered. Now DB should be, where should be, it is DB, that is 2 meter, I think. And BC, of course, it is a diagonal. So BC will be 2.82. So here now, friends, you have all the values to enjoy the final calculation. I'm not making it this table further ugly by drawing, vague lines over here. But you just try to multiply that because you know what ultimately you have to do, and this is what you have to do ultimately, and it will give you P. So use the values over here. One additional change that is to be incorporated, that you have to include EA values in the denominator. So do not forget to include that, right? And let me quickly, because it's time now, so I would like to share with you the answer for your confirmation. Just confirm it, because I know summation is not a game, easy game to be done very quickly. So I'm just sharing with you that the answer is 28.22 for p value, which is very much awaited and required. So you confirm once. I have given you the right answer, so you can cross check it at your end and confirm this at your end. I believe that all of you are comfortable with this use of energy principle number 2 in the analysis of unknown forces for the plane trusses, internally indeterminate trusses. So now in the next session, that is on tomorrow, we'll be going with the frames if possible. And I'm sure that you know how to use this energy principle now, right? So principle number 1 we have explored properly for variety of the structures. uh, this principle number 2 again we have explored on so many types of the members, like a prop cantilever, a continuously prop cantilever with more than one span. And finally today we have referred on the trusses also. This was the latest truss, right, that we have analyzed. And earlier we have already discussed one kind of simple truss like this also. So enough practice, but you need to do more practice on this, and please include the same equation that we have used here. I'm sure that you don't need input from my side in that case, so you are good enough to consider it. Here you just need to use this equation. Earlier I have mentioned it very well clearly. The only thing is you have to add AE here, that's it. So please add it here, and you'll be using that equation here somewhere, like sigma f del f upon del p into L upon AE equals to 0. So that will further refine your calculation. You just need to take summation of this sigma f, you can see here, by multiplying these two values together. So this terms will become 0 largely. Two terms will become 0 immediately, because you have a multiplication with 0 in this case. So your actual work remains within this square itself, right? Within this square itself. All right. So yes, just work out it, and I'm sure that you'll be getting your final answer like this. So friends, I'm stopping here today, and we'll be carrying on with the calculation of the member forces and reactions and other quantities in the frame tomorrow, right? So we'll see that how to apply principle number 2 for energy principle, Castigliano's second principle on frames also, because that completes our types of the variety of the structures, and then we'll go ahead with the other concepts. So thanks for joining today, and we'll meet again in the next class. Don't forget to bring your writing tools with you in the next class, so that you can work along with me. So thank you all, and take care.